Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 22 of 2014 physics paper code 8. The question is number 22 and the code is 8 and this is paper 2. Let us solve the question number 22. Students, the question is a wire which passes through a hole in a small bead. There is a small bead over here and a wire passes through the bead. So this bead and this is the wire is bent in the form of a quarter of a circle. This wire is a 1/4 of a circle. The wire is fixed vertically on the ground. This is fixed vertically on the ground and here it passes through this vertical pole and this is the bead. The bead is released from near the top, so it is released from here, so obviously it will follow this path and fall down and slides along the wire without friction. So we neglect the force of friction, the bead has to move like that. So interestingly, that if you see the wire is a semicircular type like this and the bead when it slides along that, so initially you can see, imagine that initially it has to be in contact with this upper part of the bead is in contact with the wire, but while it falls down it will be something like that. So from here to here, so this is pressing the wire and sometimes the wire, this lower part is pressing the wire. So that means we have to analyze mathematically how it is pressing the wire, the normal reaction, and we'll see that as the bead moves from A to B, the force it applies on the wire is, so initially it's supposed to be, as the intuition is supposed to be, it applies the force downward in this direction and upward in the other side. We'll see that the force it applies on the wire is, force applies on the wire. So let me first draw the diagram. The bead, this is the wire, the bead is here and it moves. So if I release it, it is something like that, and at any situation, at any point, suppose somewhere here, the bead is like so, it is moving like that. This angle is 90 given, so we have to see how this bead moves along the wire, the force it applies on the wire, how this bead exerting force on the wire, whether it is in this radially, options are radially outward like this, or radially inward like that, or radially outward initially and then afterwards inward, or vice versa, that we'll see. So first of all, we say that suppose it falls by an angle, say theta. When the bead falls by an angle theta, we will draw the free body diagram, and the velocity it acquires at that time is suppose v. The velocity it gains is b. It falls by this distance, vertical distance, and this vertical distance is suppose h. So the loss in potential energy is gain in kinetic energy. That is one equation, and suppose that the normal reaction is outward and the weight is mg acting vertically downward. Because this is theta, this has to be theta, so this component of the force is mg cos theta towards the center. So we have a situation where this equation, if I want to write that because it is moving in a circular path, there must be centripetal force. So firstly, the centripetal force is provided by F net towards center. So that is mg cos theta minus n is mb square divided by r. R is the radius of this circle. Okay, circular path. This one is the radius. This is I consider r. So this is equation number 1. Now from here I can write what is your n. N will be from here, n will be mg cos theta minus mb square by r. Now this is one equation. Suppose this is equation number 1. Now to have another equations of the velocity, because I want to write this v is unknown, and I want to write this v in terms of the known values, that is bid having mass m. This one is having suppose mass m. This distance is r I have taken, and I have to write that in terms of the known values. Here to here, the loss is mgh. The loss in potential energy is gain in kinetic energy. The bid falls by a distance h, so loss in potential energy is mgh, and gain in kinetic energy is half mv square. So from here the mass is also cancelled. The velocity v square is 2gh, but then h is also unknown. We have to write h in terms of this r and theta, because we want to analyze in terms of theta what for the force is inward and what for the force is upward. So this h is what? This is the height. This is r. This is also r. This distance to this distance r, because this is also the radius. This is also the radius. This distance is r, and this is theta. So therefore this will be r cos theta. From here to here it is r cos theta. The total is r. So this distance is r minus r cos theta. This height h is r minus r cos theta. So if I substitute over here, this is 2g h. H is r minus r cos theta, like so. So this is 2gr minus 2gr cos theta. This is your v square. If I substitute this v square that I get here in this expression of mb square by r, I will get n as follows. I will rewrite the equation of n. N is mg cos theta minus mb square divided r. I substitute the value of v square that I got, that is mg cos theta, this one, and minus m upon r. The v square I got is 2gr minus 2gr cos theta. If I solve this, the r will cancel out. This r will cancel out, and this will become mg cos theta minus, this is minus 2mg, this is plus 2mg cos of theta. This is 3mg cos theta minus 2mg. So the normal reaction I am getting is 3mg cos theta minus 2mg. So if I take mg 2mg common, mg out, this is the 3 cos theta minus 2, or if I take 2 common also, then this is 2 here and 2 there, the 2 goes 3 by 2, so this is 2 mg 3 by 2 cos theta minus 1. Here this n is this, and we will see when this n is positive and when this n is negative. So I can rather bring this 3 by 2 out, because I want know coefficient of cos theta. So this will be, I can write as n is 3 mg, 3 I am taking common, so it is cos theta minus 2 by 3. So from here we'll analyze the situation that when n is positive, this is a bead over here, the wire goes like that. Now if n is like that, n is positive, that means the bead is exerting a force in the wire in the downward direction. Force is downward, because when the bead presses it, then the normal direction goes up. So that means the force on the wire is inward. So radially inward initially. The option number D seems to be okay. It's initially radially inward. Then what happens is that, and this is possible when cos theta is greater than 2 by 3. This is possible if cos theta is greater than 2 by 3. And we know the nature of the curve of cos theta, it varies like that. So from here to here it is 90. From 0 to 90 the cos value gradually decreases. You can see that it is decreasing. So as cos theta at this value greater than this, cos theta is positive. So if the cos theta value is less than that means what? Initially it is more, because 0 to that value 2 by 3 some whatever is that angle, so up to that this is more, so in that it is positive. Afterwards this will be less than this value, because when the value drops it will be less than that. So suppose this is the cos theta value, theta cos inverse 2 by 3, this is that angle. So before that there is no problem, because that is always greater than that. So here it is positive and here it is negative, here it is positive, here it is negative. So afterwards, as the angle increases, this will decrease and becomes negative. Becomes negative means the normal reaction in this case it was like that. So in this part of the curve the normal reaction will be downward. So that means initially here, after some time the normal reaction will be like that, and therefore the force will be outward. So option number D, radially inward initially and radially outward later, this is correct. So for this the option number 4 is correct answer to this question. Okay, thank you.